Alright, so we're finally to the end of the of key features. This is the last thing we're going to go over, and again, it does get a little bit complicated and overwhelming to see so many key features. So if you have any questions, let me know. You can always go back to the video, rewatch it, but it will take you some time to get used to getting the key features. So what we're going to do here is we're going to go ahead and graph the function. As you can see, we have an absolute value function. We're going to go ahead and graph it the way I showed you, and we're going to get the key features from that function. So the domain, the range, the y-intercept, the x-intercept, the interval in which is positive, negative, where is it increasing, where is it decreasing, does it have a maximum, does it have a minimum. So we're going to go over all of those key features, and most of the key features relied on your ability to determine domain and range. So let's go ahead and dive into it. So I'm going to go ahead and graph the function. That is an absolute value function. So if you remember from our previous lesson, this is in the form of HK. So the first thing that I got to go find is my HK, which in this case is going to be 1 comma a negative 4. Remember that your H value switches the sign. Your slope in this case, notice that there's nothing there. Your slope in this case is going to be 1 or positive 1. So let's go ahead and graph it. My HK point is at 1 comma negative 4, so starting from 0, I'm going to go over 1 and down 4. My slope is positive 1, which means that my V shape is going to be facing up. So 1 over 1, and remember that there is an axis of symmetry which cuts your graph exactly in half. So I'm going to go ahead and mirror that image to the other side. Again, if you want to get more accurate, which in this case I do, you can go ahead and graph and make more points. And again, you can just go ahead and mirror those points to the other side. And there's an accurate representation of my absolute value function. Cool. So let's go ahead and get all the key features. So the first two, which are the main ones, are going to be domain and range. Remember that there's two ways of writing domain and range: set notation and interval notation. We're going to go ahead and do both. My domain, I can see, again, domain is how far is your function from left to right. I can see that my function does not stop either from left or the right, which means that my domain is going to be all real numbers. Alright? And I can write that in interval notation as negative infinity from the left, positive infinity from the right. My range, as you can see, stops at negative 4 from the bottom, and as it goes up, it never stops, because again, those arrows just mean that it goes up forever and ever. So my range is going to be, I want values that are negative 4 and up, so y has to be greater than or equal to negative 4, and I can write that as interval notation as negative 4 comma positive infinity. Remember, there's a parenthesis for infinity. Cool. Now the rest of them. So my y-intercept, basically your y-intercept is just where your function crosses with the y-axis, which is right there. So my y-intercept is 0, negative 3. I can see that I have two x-intercepts, one at negative 3 and one at 5. So that's going to be negative 3 comma 0 and 5 comma 0. Cool. I'm going to go ahead and do a maximum and minimum, and then I'm going to do the other ones because the other ones are a little bit more difficult. So maximum, it's basically the highest point of your graph. Now your graph, because it goes infinitely as it goes up, infinite is not really a value, so you cannot make infinity your maximum point. So therefore, this function does not have a maximum, but it does have a minimum. As you can see, that is the lowest point of your graph, which means that your minimum is -4. Okay, so those are the basic key features. Let's get into something more difficult. So increasing, I want to know where my function is increasing. Now what does that mean? That means that I want to know from where to where does my function have a positive slope. Well, I can see that from here to here, and notice that that function never ends. So from here to here, that function has a positive slope. Now look at the x values. We are just looking at the domain. Well, my function begins going up here, which is exactly at 1, and then it just continues to grow forever. So my function is increasing starting at 1 to positive infinity. So that is the interval, and we're going to be using interval notation for all of the other ones. Okay, so it's increasing from 1 until forever. Now it's decreasing from here, and then it stops decreasing at that point right there. And again, notice that from the left also goes forever. So that means that in every time you want to write interval notation, you want to do it from left to right, always from left to right. Now if I look at my left, it never really stops, so I'm gonna say that from my left is negative infinity, and then it stops at that point again, which is exactly at 1. Okay, notice that I'm only using parentheses. Okay, cool. Positive and negative intervals. So when it comes to knowing when your function is going to be positive and negative, I want to know what part of the function is above my x-axis and what part of the function is below my x-axis. So let's go look at my graph again, and I'm going to erase it real quick so we get a new graph. Cool. So 1 comma -4. Okay. And that's right there. Oops. And there we go. Okay. So anything that is below the x-axis is going to be negative. So all of that part of the function, it's negative. All of the function that is above the x-axis is going to be positive. So all of this is positive, and all of this is positive. Okay? Cool. So let's talk in terms of interval. Well, I can see that it starts being negative here, which is -3, and then it's negative, 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 and then it stops being negative at right here, which is 5. So my function is negative from 3, comma 5. Now when it comes to the positive, I see that there's 2 pieces. There's this piece right there, and then there's this piece right there. We have to write that separate. Okay, well, I see that point right there, it's -3. And remember, every time you're gonna write it, you gotta write it from left to right. Well, when does it start being positive? Well, it starts being positive from negative infinity, and then it stops at -3. So that's my first interval, from negative infinity to 3. Union, when does it stop? when does it begin to be positive again? Well, it begins to be positive right here, which we already know it's 5. Now, when does it stop? Well, it never stops, so it goes to positive infinity. So it's also positive from 5 to positive infinity. So 5, comma, positive infinity. Those are the key features that you're going to be asked to find for pretty much every single function that we're going to see. Okay, if you have any questions, let me know. Apologize for the long video.